In this video, we are going to be discussing about work done by constant force and work done by a variable force. That problems we are going to be discussing. Let us see the first question. A body moves a distance 10 meters along a straight line under the action of the 5 newtons. If the work done is given as 25 joules. Here you are taking a body. So here you are applying some force. This is an external force you are applying, so that the body is going to be moving a distance. Here 10 meters is given, and here for that you are doing 25 joules of the work you are doing, the angle with which force makes with the direction of the motion. So this is the direction of the motion of the body. So force with which angle it's going to be making to the direction of the motion of the body they are asking. Work done by the force which will be equal to here work done will be equal to, will be getting as W equal to Fs into cos theta you are taking, and here already it's given as work done value is given as 25 joules. Force it is going to be applied on the body will be 5 newtons. Displacement of the body you are taking as 10, and here you can take as cos theta. So 25 how many times in this sense? Here it is given as 50, and here 25 2s are. Oh, here you can take as it becomes 1 by 2, which will be equal to cos theta you are taking. It's nothing but you can write it as cos 60 1 by 2 in the sense. Here you can take it as cos theta. That doesn't mean cos gets cancelled here, right? So theta equals will be getting as 60 degrees will be getting. So force with the direction of motion, here it's making an angle 60 degrees. This is the right answer. Let us see the next question. A lawn roller is given. It is pulled along a horizontal surface through a distance 20 meters by a rope with a force of 200 Newton it's given. And here you are taking a lawn roller. This is a lawn roller, you just imagine, and here you are pulling this lawn roller with some force. It is given as 200 Newtons is given. If the rope makes an angle 60 degrees with the vertical, so here this is a force which is making an angle theta with the horizontal you can take, and here this is a vertical you can take, and this is the lawn roller you can take. So this force which is given as it makes an angle theta with the vertical, this is the vertical and this will be the horizontal, and here it's making an angle 60 degrees it's given. Then here you just resolve. If it is making an angle 60 degrees with the vertical, means here it's making an angle 30 degrees with the horizontal. Now this force I am going to be resolving. Along horizontal you will be getting as F cos 30 degrees, and this side will be getting as F sin 30 degrees will be getting. So work done by constant, the formula will be getting as W equals to Fs cos theta will be getting, and here we need to calculate the work done. W equals to force here applying as 200 Newtons. So it's going to be moving 20 meter distance it is moving. So here you can take as 20 into cos theta. Here you can take as cos 30 degrees. Force component with the displacement, here it's making an angle 30 degrees, not the 60 degrees. Be remembered, cos 30 in the sense here will be getting as root 3 by 2. So here you can take that this is 2000 into 2 into you can take as root 3 by 2, you can take 2 gets cancelled. So here the answer will be getting as 2000 root 3 joules you are getting. So the third one is the correct answer. Let us see the next question. Here a force F equal to, here it's given as 4i cap minus 3j cap plus 5k cap newtons moves a body from, so here this is the initial position vector it's given, that is you can take as r1 bar you can take, which is given as here 3i cap plus 6j cap plus 3k cap it's given, and it's moving to the another position. So let us take that is the r2 bar you can take. Now here it's given as ai cap minus 8j cap plus 5k cap. If the work done by the force is 8 joules, the value of the A they are asking. So here body is going to be displacing from one position to the another position. So first we need to calculate the displacement. Displacement equals to, here you can take as final position vector minus initial position vector you can take. So here when you are taking the I common and J and as well as K common, here you can take this is here you can write it as a minus 3 into I cap minus 14 j cap will be getting, and this is 5 minus 3 will be getting, this is R2, right, plus 5 minus 3 will be getting, and here you can get it as plus 2k will be getting, this is plus 2k. So this is the displacement vector will be getting. Work done, you know the formula f bar dot s bar will be getting, right? If two vectors you are getting in this sense, do the dot product. So here you can take as force value is given as 4i cap minus 3j cap plus 5k cap dot s bar in the sense here we will be getting as, this is a minus 3 into I cap minus 14j cap plus 2k cap will be rating. And here you just do the dot product, you know this rule here, I cap dot I cap which will be equal to j cap dot j cap which will be equal to k cap dot k cap, that you can take it as 1 you can take. Now here you just simplify this equation. Work done is given as already 8 joules is given. Do this dot product here. Here we will be getting as this is a minus 3 and here it will be 4, a minus 3 into 4. So I cap dot I cap will be getting as 1 will be getting. At the same time here you will be writing as I cap dot j cap dot k cap dot I cap which will be equal to 0 you are taking. If you are doing the dot product with the I, j, k, right, so here you are getting as 0. Just do the dot product with the same, right, Cartesian coordinates. J cap dot j cap, here you can take as minus into minus will be getting as plus will be writing. So 3 into 14, so here we will be getting as 42 will be getting this 5k cap and as well as 2k cap. So plus into plus will be getting as plus, 5 2 0 will be getting as 10 will be getting, k cap dot k cap will be 1 will be getting. So here when you are simplifying this one here 4a minus 12 plus 42 plus 10, 52 you are getting. So when you are simplifying this equation here the a value, the value of a they are asking. So a value you are getting as minus 8 you are getting. So this will be the correct answer, a equal to minus 8. Let us see the next question. Here a body constrained to move along the z-axis. Body is moving along the z-axis. So here a displacement vector it's given as here along z-axis, means here Cartesian coordinate you can take as k cap you can take. It's being applied by constant force is given as f value. F is given as 2i cap plus 3j cap plus 4k cap it's given. Now here find the work done by this force moving the body over a distance of 5 meters along the z-axis. So 5 meters distance it's moving along the z-axis. Now we just calculate the work done. So W equals, you know the formula here f bar dot s bar you are taking, and here the two vectors is given. Displacement is a vector quantity. Here you can write it as 2i plus 3j plus 4k cap dot, here you can take it as 5 cap you can take. So here I cap dot k cap value will be 0, j cap dot k cap value will be 0, but k cap dot k cap will be 1 will be getting. So 4 into 5 will be writing as 20 will be writing. So here the work done value will be getting as 20 joules you are getting. So this will be the correct answer. Now let us see the next question. A force of here 5 newtons right is applied on a 20 kg mass at rest. The work done in the third second they are asking. So whenever you are calculating the work done, first you have to calculate displacement covered by the body in the third second, you just calculate. So here you know a kinematic equations, displacement covered by the body is Sn equals will be writing as u plus a into n minus half. N represents the time, a represents the acceleration, right? Here initially the body starts from the rest is given 0 plus a in the sense here right, acceleration they are not given, but here according to second law of motion a equal to you can write it as f by m, and here they are asking third second, so here you can take as 3 minus 1 by 2 you can take, and here force value it's given as 5 newtons, by mass it's given as 20 kg, so 2 3 is 6 minus 1 is 5 by 2 will be getting. So here you can take as 5 4 z, so here we will be getting as 5 by 8 you are getting. So this is the displacement covered up by the body in the third second we will be getting. So now they are asking work done value, work done which will be equal to, here you can take as f bar dot s bar So if the angle they are not given in this sense, almost you have to take as theta value you can take as 0. So here you can take as F into Sn, you can take displacement covered in the nth second. F into Sn you are taking means here force value will be getting as 5 into, you can take as 5 by 8, which you can take as 25 by 8 joules you are getting. So this will be the correct answer. Let us see the next question. A 5 kg box rests on a horizontal surface. So here it's given as one 5 kg box which is resting on a horizontal surface is given. So the coefficient of the kinetic friction between the box and the surface is given as 0.5 is given. Means here you are placing this box on a rough surface. So you are placing on a rough surface. So this So here you are applying the force here, it's given as 5 newtons here. This is the force you are applying on a rough surface. Coefficient of the kinetic friction is given as here mu k is given as 0.5. A horizontal force pulls the box with a constant velocity for 10 centimeter. Right? The displacement of the body is given. So here 10 centimeters you are going to be pulling the body. Now here they are asking the work done by the applied force and as well as the work done by the frictional force they are asking. So first we need to calculate the net force value. Here F net which will be equal to. So here when you are pulling the body along this direction, and here a frictional force is going to be acting opposite to the direction of the motion of the body. So net force in the sense here applied force minus external force you can take. And here but body is moving the constant velocity, means here net acceleration will be 0. So force also you can take as 0 you can take. That means here we will be getting as F minus F. That doesn't mean here you can take as applied force which is nothing but the frictional force will be getting. Now what is the frictional force acting on a body? So F equals to here will be getting as mu into N. N is nothing but here you can take as here this is a normal reaction, and here weight of the body it lags downwards. Mu into N which is nothing but here will be writing as mu into M into G or taken. So here already it's given coefficient of the kinetic friction is given as 0.5 is given, mass is given as 5, and here you can take as Z value you can take as 10 you can take. So together we will be writing as this is 25 newtons you are getting. 25 newtons you are getting. Now here applied force which is nothing but the frictional force will be getting. This is very very important, and here now we just calculate here according to the requirement work done by the applied force they are asking. So here you can take work done by applied force, work done by the applied force which is nothing but you can take as W equal to F into S you can take. Here already we got it as 25 into displacement of the body is 10 centimeter, you can take as 10 into 10 power minus 2 meter, we can write it as 2.5 joules will be getting. And second question they are asking work done by a frictional force. Work done by frictional force in the sense here body is displacing along this direction, frictional force body is going to be moving along this direction, but frictional force is going to be acting like this. And work done by frictional force in the sense here F into S into here you can take as cos 180 you can take. Angle between the displacement and as well as frictional force will be 180 degrees will be getting. And here we will be getting this is 180 degrees you can take. Cos 180 is minus 1, so minus F into S you are writing. So here you can take as here almost will be getting as force value will be same. Applied force is equal to the external force. Frictional force is nothing but the applied force, so that you can get it as 2.5 joules will be getting. But this is the minus value will be getting. Right? Minus 2.5 is the correct answer. Work done by the frictional force is minus 2.5 joules. Work done by the applied force will be 2.5 joules. So fourth one is the correct answer. Now let us see the next question. A person of mass 50 kg carrying a box walks up a staircase. The height and as well as width is given. Height, how much it is given? Width and height of the each step is given as 20 centimeter and width is given as 15 centimeter. The work done in walking up 50 steps is 7840 joules. The mass of the box they are asking. Here it's given as, here one staircase it's given. And here it's given as, this is 0.15 centimeter is the width is given, and here we can write it as this is 0.15 meter is the width, and here height is given as, this height is given as 20 centimeters. So here this height you can take as 0.2 meter you can take. Like a person is going to be climbing, person mass is given, and here he is carrying a box, right? He is carrying a box. So let us see, mass equal to 50 kg, and here they required here mass of the box they are asking. Now here if the person is doing some work against the gravitational force, in the sense you can take work done can be stored in the form of the gravitational potential energy. Total height climbed, in the sense here you can take as total height 50 steps will be there. Each step width, it's h is the width of the each step, height of the each step you can take as h you can take. So you'll be writing as 50 into you can take as 0.2 meter you can take. So total height will be getting as, total height climbed by the person will be getting as 10 meters will be getting. So work done can be stored in the form of the potential energy. Then you can write it as total mass, in the sense here a person mass and right box mass will be m into you can take as z into h. This total work done is given as 7840 joules, which will be equal to, so capital M will be is given as 50 plus small m we don't know. Let us see here m, and g value here you can take as 9.8 into you can take as 10 you can take. So here this is 50 plus m, which you can write it as 7840 by, here you can take as 9.8 into 10 will be getting as 98. So together we will be getting as, here this value will be getting as 80. Then mass, when you are simplifying 80 minus 50, so you will be getting as 30 kg will be the correct answer. So this is the box which you are going to be climbing. So now we can talk about the horizontal force. Here about the horizontal, here force which is going to be carrying along this direction, right? Along horizontal direction, and displacement also will be along the same direction. So here a force due to gravity, in the sense here it will be acting downwards. Force due to gravity along this downwards will be getting, and here displacement of the body will be getting as along this direction. Both they are making an angle 90 degrees. So here along its width, right, fs cos 90 will be getting, here cos 90 value will be getting as 0. So here though if it is climbing the width, here it doesn't have any importance in the question. So why? Because work done value along its width will be getting as 0 will be getting. So work done by the gravitational force, here you can take as mgh, here minus value will be getting, here I am just calculating only the magnitude. Let us see the next question. Here it's given as, find the ratio of the work done by the gravity on the block under the two conditions, assuming mu value will be 0. Mu is 0 in the sense here it's a smooth surface and its plane is given. What's the ratio of the work done by the gravity? Work done by the gravity doesn't mean here it only depends on the height, right? So here you can take work done by gravity. Work done by gravity will depends only on height h, and not on the length of the inclined plane. Length of the inclined. So here in both the cases, here you are releasing the body from h height. So here in the two cases, here it will be
So it's an independent of the length. So here you can take as W1 is to W2, which will be equal to, you can take as 1 is to 1, you can get. Let us see the next question. The work done in moving a body of mass 5 kg from the bottom of the smooth inclined plane to the top, it's given as 50 joules. Here you are taking one inclined plane, you are taking this is an inclined plane you can take, and here you are taking one body you are going to be taking. This is here you can take as it's a 5 kg mass you are going to be taking, and here you are taking from the bottom on a smooth inclined plane, and here this weight it's going to be acting downwards, but here it's making an angle 30 degrees it's given, and here you can take this is about the normal reaction. So where the surface is contacting, that you can take as right perpendicular to that surface, you can take as normal reaction. And here you can take mg when you are resolving. Here this is making an angle 30 degrees. This will be mg cos 30 will be getting, and here perpendicular to this one will be getting as mg sin 30 will be getting. Mg sin 30 will be getting. So you are applying some force. So here this force here along this direction, and here this is the length of the inclined plane you can take. Here length of the inclined plane I am taking as L I am taking. Now here you just calculate the work done value. Work done already it's given as 50 joules. Length they are asking. So W equals, here you know the formula, force into displacement. So force here it's given as here force can be, here this force will be equivalent to the mg sin 30 component. So here I am just writing as mg sin 30 into, you can write as force and displacement both will belong the same direction. Displace is nothing but here length of the inclined plane you can take. Then W equals, you can write it as here it's given as W already it's given as 50 joules it's given. Now here you can take this is 50 joules, which will be equal to mass it's given as 5 kg. G value you can take as 10 you can take, sin 30 is 1 by 2 into length of the inclined plane you can take. So here this 50 and 50 gets cancelled. So length of the inclined plane will be getting as, by taking LCM, here will be getting as 2 meters will be getting. So 2 meters is the correct answer. Let us see the next question. A uniform chain of length L and mass M hanging down vertically from a hook fixed to the roof. The work done in hooking the other end of the chain is shown in figure. In fact, here work done by the gravitational force when you are talking, work done by gravitational force so here we can write it as, that is minus mgh you are taking. Here h is nothing but, you can write as, where h is nothing but height gained by the center of gravity height gained by center of gravity of the body. So any uniform body when you are talking, this center of gravity here you can take here. Initially the center of gravity is going to be lying at L by 2 distance. Now by doing some work in hooking the other end of the chain at the right as shown in figure. When you are hooking this one, now the center of gravity here you will be shifting, here it's going to be shifted, so exactly half. So for any linear body or uniformly body, center of gravity will be at a height will be getting as half will be getting. L by 2 distance you are hooking in the sense here to the upper end. So this height of center of gravity will be where it is located in the sense at, again here it will be L by 4 distance. This is a center of gravity in the second position you can take. So here you can write it as Wg, which will be equal to, here will be getting as minus mg into this height of center of gravity for the new position will be getting as at L by 4 distance will be getting. Here in the options minus value is not given, just you can take the magnitude alone. So here will be getting as mgl by 4.
Next question, you just look at a block of mass 10 kg is placed on a rough surface. Now here it's inclined at an angle 37 degrees with the horizontal. Here a block we are placing. Now the block is released. The work done by the gravitational and frictional force are asking. When the block moves from A to B. So A to B, the block is going to be moving. Here I just look at this displacement is given. And here it's making an angle 37 degrees. Here 37 degrees in the sense here you can take inclined plane given as 37 degrees, it's given means here this 3 you can keep like this, and here adjacent side you can take as 4 you can take, and here hypotenuse you can take as 5 you can take. Now here we can talk about the two important forces, and with this here we can calculate cos 37 value. Cos 37 is adjacent side by hypotenuse, so here we will be getting as 4 by 5, and at the same time sin 37 value will be getting as opposite side by hypotenuse. So now here we can talk about the work done by the gravitational force, and here at this position when it's moving in the sense here you can take its weight, it's going to be acting downwards. Normal reaction, it's going to be acting like this perpendicular to the surface where it is contacting, and here it is also 37 degrees. And here now we just resolve, this is mg cos 37 degrees, and here this side will be getting as mg sin 37 degrees will be writing. So now here the body is moving from A to B in the sense here force, which force means here mg sin 37 component, it will be moving down, and displacement also will be along the same direction. Then work done by the gravitational force here you can write as in downwards mg sin theta into displacement will be L. So both will be along the same direction, so that you can take as theta value will be 0 you can take. So here you will be writing as mass, here it's given as 10 kg mass, and acceleration due to gravity 10 you can take. Sin 37 value you can write it as 3 by 5 into length. Length is given as 10 meters is given. So here you can take 5 2z, 3 2z 6, 6 into 100 is 600 joules will be getting. Work done by the gravitational force, whereas in this case here it will be positive alone will be getting. So you are releasing the body here, both force due to the gravity and the displacement both will be along the same direction. So here work done by the gravitational force will be 600 joules you are getting. Now let us see the next scenario here. Frictional force they are asking. So frictional force doesn't mean here it's a rough surface it's given. When the body is moving down in the sense here frictional force is going to be acting opposite direction. Then I can take work done by the frictional force in the sense here F into L into length of the inclined plane into angle between the two vectors will be 180 degrees here. Cos 180 is minus 1, then you can take as F into L you can take. But this frictional force also it's going to be FL equals here F in the sense here mu into N. F equal to will be writing as mu into N. NB can be balanced here you can take as mg cos theta you can take, that is nothing but cos 37. Here I am just substituting these values mg cos 37 into L value. Now here minus mu in the sense here we will be writing as 0.2. Mass here it is given as 10 kg, g value 10 you can take, and here cos 37 in the sense here we will be writing as 4 by 5 into length is nothing but 10. So when you are simplifying these values here, work done by the frictional force, so here you can take as 5 2s are you can take, 2 4s are 8, 8 into 100 is 800, 800 into 0.2 will be writing as nearly minus 160 joules will be getting. So this will be the correct answer. Now let us see the next question. A ladder is given AB of 2.5 meter long and weight is given as 150 newtons. So initially you are taking on ladder, you are taking this is a ladder, you just imagine. This total weight is given as 150 Newton and this length is given as 2.5 meter and this total weight is given as 150 Newton. a 40 Newton weight is attached to the end B. Here you are going to be adding one 40 Newtons force you are going to be adding. The work done to be arrange the ladder in a vertical position with the end A is in contact with the ground. So here almost you can detect this end A is in contact with the ground I have taken already. Now this is a work done by the work done to arrange the ladder in the vertical position. So total work done is nothing but you can detect as work done to keep the ladder in the vertical position. Along with that, here you are doing some work against the gravitational force. You are bringing the body right up to this height, 2.5 centimeter. So work done by the ladder, in the sense here ladder it's given as 2.5 centimeter it's given, and here the center of mass of the distance is given as 1 meter. So total ladder center of mass and center of gravity is given as at 1 meter distance is given. This is center of mass is given. So here mg into displacement, work done equals to, here you can write it as force into displacement. Force is nothing but weight of the ladder you can take. Weight of the ladder it's given as 150 newtons. So here you can take as W equals to, here you can take as 150 newtons into length is nothing but height of center of mass you can take, plus work done by the body. Work done by the body in the sense here W equal to mg into here up to what height you are keeping the body, in the sense here you will be writing as 2.5 newtons, 2.5 you can take displacement. So total work done is nothing but, here you can write it as this is 150 plus here 4 into 2.5. So 25 4 will be getting as 100 will be getting, so together will be getting as this is 250 joules here. So total work done value here it will be 250 joules. So for uniform body you can take the center of mass or center of gravity you can take. Here already in the question it's given as 1 meter distance is located, and here second thing is here body they are given, body and displacement they are given. Displacement it's nothing but 2.5 meters distance. Now just look at the next question. A bucket filled with the water having a mass 15 kg is raised from a well of depth 12 meter it's given. If the work done to do so is 2160 joules, the linear density of the rope they are asking. So be remember here this definition, linear density. Linear density of the rope is nothing but rho equals to, you can take as mass per unit length you can take. So linear density here it's given as the linear density of the rope we need to calculate. So here a mass here you can take. That means here the linear density of the rope there also, right? Now here let us see the question. So here this is the well you can imagine. This is a well you just imagine. Here you are lifting the water. With the help of bucket you are going to be lifting the water. Lifting height also you can take as depth of the well you can take, that is 12 meter with the rope. So you are going to be lifting this one, right? Now here this is here 12 meters is given, means here center of gravity you can get it as. So here for the rope, here where it is located in the sense, here center of gravity for the rope it will be located at 6 meter distance is located. Now here you are doing two works. One is work done to pull the rope, and second thing is here work done to pull the bucket. Work done to pull the rope is nothing but, here we can write it as that is work done to pull the bucket. That means here we can write it as this is m2g you can take. This mass of the bucket here, bucket filled with water having a mass is given as 15 kg. This is here you can take as, or else first you can talk about the bucket. So here you can take as bucket m1 into g into you can take as bucket you are pulling up to 12 meter distance plus, so second one rope mass we don't know, let us take as m2 into g into, here you are pulling the rope. Rope is a uniform body. For uniform body height of center of mass will be located at 6 meter distance. So here you can take as 6 meters. total work done is given as 2160 joules, which will be equal to mass of the bucket is given as 15 into 10 into 12, which will be equal to M2 into, you can take as 10 into 6, you can take. Now here this is nothing but 2160, which will be equal to, here you can write it as this is 15, 12 into 15, 180, 180 into 10 will be 1800 will be getting. That 1800 you have to bring this side towards left side, here you will be getting like this, and this is nothing but here M2 into 60 you can take. So here it's nothing but M2, which will be equal to, you will be getting as 360 by, here you are writing as 60. So here 6 times it's going, so mass of the rope will be getting as 6 kg you are getting. But in the question they are asking as a linear density of the rope they are asking. Linear density of the rope is nothing but mass per unit length you are getting. Mass of the rope will be getting as 6 by length is given as 12 meter distance. So here are 6 1 time, 6 2 times, here will be getting as 0.5 kg per meter. So this is the correct answer here. Let us see the next question. A block of mass m is lowered with the help of the rope of the negligible mass through a distance d with an acceleration of z by 3. Work done by the rope on the block is. So here a block is given. This is a block you conduct as m you conduct. This mass you conduct as m you conduct. You are lowering the block. So you are just lowering this block. With what acceleration in this sense? Here with an acceleration is given as z by 3 it's given. Now here this is a wire you conduct, here wire when you are lowering, here this weight it's going to be acting downwards, and here a tensional force here it's going to be acting like this. The net force when you are lowering in the sense F net, which will be equal to, you can write it as MA you can take. F net in the sense here when you are lowering down in the sense here weight is going to be more, you will be getting mg minus t, which will be equal to, you can take as m into a. With what acceleration it's moving in the sense z by 3 you can talk. Now we can take here, just calculate, so that t equals to, you will be writing as mg minus mg by 3 you can take, which is nothing but here 3 mg minus mg will be getting as 2 by 3 mg you are getting. This is the tensional force in the rope will be getting. Now just calculate here work done by the rope they are asking. Work done by the rope is nothing but, work done value will be work done is nothing but tension force into displacement, right? Some d displacement, a distance d distance is going to be moving. So tension force is going to be acting upwards, displacement of the body it's going to be acting downwards. So both are making an angle 180 degrees. So cos 180 you can take, it's a minus 1 will be writing. So minus 2 by 3 into, this is here you can take that, this is capital MG I have taken, this is, sorry, here this is capital MG you can take, this is capital MG, and here also you can take as capital MG. 2 by 3 into capital MG into, here a displacement is given as D is given. So here you can take as work done to pull the, release the rope body in the sense W equals to minus 2 by 3 into mg into dr. So this is the correct answer. Let us see the next question here. A light inextensible string that goes over a smooth pulley. It's given as figure connects a 0.3 kg mass and 0.72 kg mass taking g equal to 10 meter per second square. Find the work done by the string on the block of mass 0.3 kg during the first second after the system released. So first second they are asking. So here you can take here this side here tensional force is going to be acting like this here, whereas here this is a heavier body, so acceleration will be getting downwards, and this side it goes up. Now here this is a tensional force is going to be acting, right? Now here we can talk about with what acceleration the system is moving. This is like an attitudes machine. It's an attitudes machine. It's an attitudes machine concept. If two masses is given, one is heavier mass, you are hanging to a pulley, two masses, same rope you are going to be hanging, then same tensional force is going to be acting, and same acceleration also it's going to be experiences. Then acceleration experienced by the system in attitudes machine, here A equals to, you can write it as capital M is nothing but weight of the heavier one, mass of the heavier body conduct minus small m by, you can get it as this is capital M plus small m into G conduct. So this is a fundamental fundamental relation you'll be getting from the at its machine concept. You will remember, students. Now here you just simplify here. Capital M is given as 0.7 kg, 72 kg minus 0.36 kg by capital M plus small m. Here will be written 0.72 plus 0.36 into E conduct as Z conduct. When you are simplifying this one, here will be getting as 0.36 by, here will be writing as 1.08 into 10 E conduct. So here 0.36, 36, 3 times it's going. So here you can write it as 10 by 3 meter per second square will be getting. So the system moving with an acceleration, we got it as 10 by 3 meter per second square. Now here let us calculate the displacement of the block in the first second. Displacement of the block in first second. Displacement is nothing but here you can write as S equals to, you can write as ut plus half at square you can take. Initially the system you are releasing from the rest in the sense, here you can write as initial velocity will be 0, half into a value will be writing as 10 by 3 into t square. First second means here 1 square you can take. 2 5s are here, you can write it as 5 by 3 meters you are getting. Now here on the first body, in the sense, here you can take the free body diagram. And the free body diagram here, when you are talking here, this is 0.36 kg mass you can take. Mass here, tensional force is going to be acting, and here weight is going to be acting downwards, and the body is going to be accelerating upward direction. Net force is nothing but while it's going up, in the sense here this is T minus mg, which will be equal to net force is nothing but mass into an acceleration. Together T equals will be writing as m into g plus a. So mass, you know, here for the first body, here it will be 0.36 kg into here g value you can take as 10 plus 10 by 3. So when you are simplifying this one, here you will be writing as this value you will be getting as nearly 4.8 newtons will be getting. So tensional force you are getting. Now you can calculate the work done value. Work done is nothing but here you can take as T into S into cos 0 you can take. Both the tensional force and as well as here displacement also will be along the same direction. So you can take cos 0 value. Here tensional force already we calculated 4.8 into displacement covered in the first second means 5 by 3 meters we got. 5 by 3 can take 3, how many times? 1.6 into 5. Nearly 8 joules you are getting. So this will be the correct answer. Now let us see the next question. The work done in lifting a body of mass 20 kg of specific gravity is given 3.2. Specific gravity is nothing but here you can take as density of the substance by density of the water you can take. So specific gravity value is given as 3.2 is given. So here you have to take 3.2, which will be equal to density of the body by density of the water you can take. Water density will be getting as 1 gram per cc. So then density of the body you can get it as 3.2 gram per cc you can talk. Now here you can see work done to lift the body. So here you are taking the body will be inside the water. Now we are going to be lifting this body here up to 8 meters distance we are going to be lifting. Now what are the forces acting on this body means here weight of the body it will act downwards, and here upward forces here it will be your applied external force along with that buoyancy force is going to be acting. So net force when you are talking here, this is your external force plus FB net force you can talk in the equilibrium position, which is nothing but mg you can talk. Then F work done in lifting a body, lifting force they are asking, so that here you can take as mg minus fb you can take. So buoyancy force, one more formula you can write it as mg into density of the liquid by density of the body you are taking. Now here when you are substituting this body here, F equals to here will be getting as mg into here 1 minus density of the liquid by density of the body you are getting. When you are simplifying this one, work done, force you got, now work done which will be equal to force into displacement you can take. Force and your external force and displacement both will belong the same direction. So theta value will be getting as 0. So here you can write as mg into, so 1 minus density of the liquid by density of the body into displacement is nothing but height you can take. Now this mass it is given as here 20 into 10 into 1 minus density of the liquid is 1 gram per cc by density of the body, now we got as 3.2 into h value up to 8 meters height you are taking. When you are simplifying this, all the values here will be getting as 1100 joules you are getting. This will be the correct answer. Let us see the next question. 1/4 of the chain is hanging down from the table. Now here you are taking table you are taking, and here you are going to be hanging there's a chain you are going to be hanging. So let us say here a total mass of the chain. Total mass of the chain. Total mass of the chain, let us take here it is capital M you can take. In that hanging part of the chain. Hanging part of chain. Hanging part of the chain you are getting B. So when you want to calculate here, first you have to concentrate here. Suppose in the total length, this is the total length of the chain you can take, this is the total length. In that here x portion is going to be hanging portion. Hanging part of the chain is nothing but here you can talk about total mass by total length into length of the hanging portion, let us take as x you can talk. So here you can take here work done which will be equal to the formula will be getting, and you are applying the force. So you are doing some work to bring the hanging part of the chain onto the table. You are applying the force along this direction, displacement also will be along the same direction will be getting. W equals to here you can take as integral you can take as f bar dot s bar you can take. F bar dot here you can get it as dr bar you can take. So f and dr bar will be along the same direction displacement here. So from 0 to here you are going to be bringing 1/4 of the mass here, 1/4 of the hanging portion you are bringing. Now here you have to substitute here it's nothing but mg by L. Force is nothing but mg, mass of the hanging portion will be here will be getting as m by L into x. Right, so that mg by L into x into, so here you can take small amount of the displacement you can take as some dx you can take. So you are bringing from 0 to L by 4 distance you can take. Now here the work done which will be equal to here you can take as mg by mg into integral x dx will be getting. So integral x dx the formula will be getting as x square by 2 will be getting. So now here you can take as here x square by 2 between the limits when you are substituting x square by 2 between the limits you can take as 0 to L by 4 you can talk. Now here you have to simplify this one. W equals to here you can get it as mg by here 2 you can take outside, L square in the sense here L square by 16 you will be getting, 16 minus 0 you will be getting. So which is nothing but here you can take as mgl by here will be getting as 32 you are getting. So here mgl by 32 is the correct answer. Now let us see the next question. A uniform chain of mass m and the length is given as L is kept in a horizontal table with half of its length hanging from the edge of the table. Work done in pulling the chain onto the table so that only 1/5 of the length is now hanging from the edge. Now here you can take, here it's given as, so this is the chain you are going to be hanging. Initially here it's a half of its length is going to be hanging. Half of its length is hanging. So total length if you are taking as L, in that here you can get it as This is the total length of the chain, you can take as L, you can take. This is the total length of the chain. In that, here X is the hanging portion of the chain, you can take. Right? Now here force which you are pulling this side, and the displacement also will be along the same direction you will be getting. Then force acting on the chain to pull the body in the sense here. First you have to calculate how much mass it is going to be hanging. Mass of the hanging portion is mass of hanging portion. Mass of the hanging portion is here we will be writing as total mass by total length into length of the hanging portion will be getting as X will be writing. Force is nothing but here mg will be getting. Then here what you can write here, m by L into X into G are getting. This is the force value. Now you have to apply the work done value. Work done to pull the rope from where to where in the sense here L by 2 distance to L by 5 distance. Then here you have to simplify this one. Force into displacement, they will be along the same direction. M by L into X into G into you can take as dx. This is the force into displacement. So now you have to take the outside m into here you can take. So this is the mass of the body, you can take as m, you can take m into here you can take as z by L into integral x dx in the sense here we will be writing as x square by 2, but in the limits you can take as L by 2 to L by 5 you can take. Now here work done which will be equal to you can take mg by 2L, 2 you can take outside, which is nothing but x square by 2. Instead of x you have to put the value here L by 5 when you are substituting it becomes L square by 25 minus, instead of x again you have to put the value upper limit minus lower limit L square by 4 you are getting. So when you are simplifying this one here you will be getting as mg by 2L into here you can write it as this is L square also you can take outside, and here you can get it as 4 minus 25 by here we will be getting as 100 you are getting. One LL gets cancelled, then work done, total work done which will be getting as, so this is minus we will be getting of course minus mg into L into this is 21 by here we will be getting as 100 into 2. It's a 200 you are getting. So this will be the right answer. So here only magnitude alone they are talking. Here mg into 21 mgl by 200 is the correct answer you are getting. Let us see the next question. Here it is given as a small block of mass m is kept on a rough inclined surface of inclination is given as theta. It is fixed on the elevator. The elevator goes up with a uniform velocity. Elevator is going to be moving with the uniform velocity and the block does not slide on the wedge. Now here let us see here it's given a row elevator it's given. It's an elevator it's given. Inside here you are keeping one inclined plane you are keeping. So now here you are keeping one box here. A small block of mass m is kept on a rough inclined plane. This is here mass you are keeping like this. Now here which is making an angle theta is given with the horizontal. Now here you can talk here this is weight, it's going to be acting downwards, and this is about the normal reaction, and here you just resolve. This is theta of course, mg cos theta I will be getting, and this is mg sin theta I will be writing. Now here it's moving at the uniform velocity it's given. Uniform velocity. So body if it is moving in upwards, displacement of the body also will be it's going to be moving downwards, right? So when it's moving up here you can talk displacement, you can talk along this direction. So this is a normal reaction, and frictional force here it's going to be acting along this direction. Frictional force here opposite to the direction of the motion, frictional force is going to be acting. So friction, this is theta in the sense here you can get it as this is this value almost will be getting as 90 minus theta will be getting 90 minus theta. Now here you can talk displacement of the block in time t seconds, which is nothing but velocity into time. So here elevator is moving upwards. That means here block also it's going to be moving. That is, block also moves with same speed, with v speed only it's going to be moving. Now you can talk about work done by the frictional force. Work done by the force of friction they are asking. Work done by the frictional force is nothing but here you can take as F into S into cos theta will be written. So between frictional force and displacement here it will be mg sin theta. It's a balanced force. Displacement is nothing but Vt you can take. Cos theta in the sense here you can write it as cos 90 minus theta you are writing. So cos 90 minus theta will be sin theta. Sin theta into sin theta is sin square theta will be getting. So work done by the frictional force is nothing but here you can write as mg into v into t into here you can get it as sin square theta. So this is the correct answer. Now let us see the next question. A well is in the form of the cylinder. The radius is given as 3.5 meters. Water surface in it is given as at a depth of 15 meters. And the depth of the water is given as 10 meters. Work done in draining out half of the water from it is. Now here half of the water you are going to be draining. So here you just look at here it's given a well is given. Cylinder, it's a well is in the form of cylinder of radius is given as 3.5 meter. Water surface in it is at a depth of 15 meter it's given, right? So here it's nothing but 15 meters, right? Up to this height you can take. Depth of the well you can talk. And the depth of the water column is given as 10 meters. Water column is at a depth of here it's given as up to 10 meters it's given. So here you will be getting up to 10 meters distance. So you are going to be draining the water half, right? This half of the water you are going to be draining. Half doesn't mean here we can get it as this height of center of gravity. This is the height of center of gravity will be located at, right? This is 15 in the sense and this is 10 meters you are getting. So here you will be getting as at half in the sense here. So 15 plus here we will be getting as this will be this height of center of gravity. Here you can talk about height of center of gravity. The remaining value will be here this is 10 and here this will be center of gravity will be located at 2.5 meters distance it will be located. Now here work done is nothing but here you can take as mgh you can take. Its mass is nothing but here you can take as volume into density of the water into g into h you can take. W is nothing but rho into volume in the sense here area into length you can take into g into h you can take. Which is nothing but density of the water value is 10 power 3 into area in the sense pi r square you are taking. Length is nothing but here you can take as 5 meter you can take 5 meters into here g in the sense here you can take as 10 you can take. Height of center of gravity in the sense here you can take as 15 plus this is nothing but 2.5 you will be getting. So here you will be getting as this is nearly the work done value will be getting as 33.7 megajoules. Now let us see the next question. A weight lifter jerks 220 kg vertically through. It's given as 220 kg. So now and holds still at that height for 2 minutes. The work done by him in lifting, in holding it, still it is respectively. So work done here, what the formula will be getting? Work done by the lifter to jacks 220 kg vertically through 1.5 meters. So work done by the gravitational force or against the gravitational force, here we can write it as, this is mgh you can take. So minus value I am not going to be taking here, which will be equal to, here this is 220, mass will be 220 into g value will be getting as 10 into, here you can take as 1.5, which is nothing but nearly will be getting as 3200 joules you are getting. 3200 joules. Second thing is work done by him in lifting and holding, right? So here in holding, displacement value, if holding, displacement is 0. Displacement is 0. So then work done value also here will be getting as 0 here. So 3.2 here, its closed value is given as here 9.8 when you are substituting here, nearly will be getting as 3234 joules and 0 will be the correct answer you are getting. Now let us discuss about here the next thing is here work done by the variable force questions. The first question says here a position dependent force F is given 7 minus 2x plus 3x square Newton acts on a small body of mass 2 kg and it displaces x equal to 0 to x equal to 5 meters. The work done in joules they are asking. So work done here for a variable force, in the sense here you can talk about F into dx you can take 0 to here you are displacing 0 to 5 meters, which is nothing but we can take as force value is given as 7 minus 2x plus 3x square into displacement you can take as x you can take, between the limits you can take as 0 to 5 you can take. Now you can take here w equals to 7 into integral 7 into dx is integral dx is x will be writing minus 2 into integral x dx is x square by 2 plus 3 into integral x square dx, x cube by 3 you are getting, between the limits 0 to 5 you can do. Now when you are substituting these values here, w equals here, this 2 gets cancelled, 3 gets cancelled, w equals here we will be writing as, you just put the values, 7 into 5 will be getting as 35 minus this is 25 plus it's a 125 you are getting, so which will be equal to, here we will be writing as 135 joules you are getting. Let us see the next question here. Find the work done if a particle is displacing from 1 meter, 2 meter and 3 meter to 2 meter, 3 meter and 4 meter and a force of, here it's a variable force is given. Then you have to take work done by the variable force, which will be equal to, here you can take, here position vector it's given from r1 to r2 bar you can take, that's nothing but f bar dot dr bar you can take. Dr bar is nothing but here you can write as dx I cap plus dy j cap plus you can write it as dz k cap you can write. So only here when you are talking about x coordinates, here w equals, here you can write as this is f1 you can take f1 into dx I cap dot I cap will be getting as 1 will be getting. Then here limits you have to take from x1 to x2. This is 1 meter is the x1 value, here it's a y1 z1 you can take, and this is x2 y2 z2 you can talk, plus here this is y1 to y2, here you can take as f2 into dy, fy into dy you can take, plus here you can take as z1 to z2, here you can take as fz into dz you can talk. So now you have to integrate the things. Here you will be writing as force value, you know, this is here only x component element you can talk. This is nothing but 2x into dx, between the limits here you can take as 1 to 2, plus here y1 to y2, 2 to 3 you can take limits, fy value is given as 3y square, this is 3y square into dy you can talk, plus here 3 to 4 you can talk integral limits, so fz is given as 4z cube is given, 4z cube into dz. Now just put the values here by doing integration and all. Here W equals to, here we will be writing as 2 into, here it is an x square by 2 between the limits 1 to 2 plus 3 into, here y cube by 3 between the limits you have to take as 2 to 3 plus 4 into z power 4 by 4 you are getting between the limits you can take as 3 to 4 you can take. So when you are simplifying this one, again here we will be writing as, here you can take W equals to, here we will be writing as, so here 2 2 you have to cancel, 3 3 you have to cancel, 4 4 you have to cancel by taking outside common. So x square in this upper limit will be 2 square, which 4 minus lower limit will be 1 square plus, and here upper limit will be y cube. So instead of y you have to put the value 3 cube is nothing but 27 minus 2 cube in the sense 8 plus, and here 4 4s are 16 16 there will be 256 minus, it's an 81 you are getting. So the answer will be getting as work done value, it's a 197 joules you are getting. This is the correct answer. Let us see the next question. The relation between the force and position is shown in the figure. The work done by the force in displacing the body from x equal to 1 centimeter to x equal to 5 centimeter. So here some graphical question it's given. Here you can talk about work done, which will be equal to area between force and displacement. You can force and displacement. So here first you can talk about the work done. Here this will be showing the square, right? So area in the sense here you can get it as, this is here you will be writing as length into breadth you can take. This is 10 into you can take as 1 you can take. And next when you are coming this side, so from 2 to 3 when you are talking, 2 to 3 when you are talking, here you can take this is a rectangle 2 to 3. So here we will be getting as force value will be getting as 20 you are getting. Displacement 3 minus 2 will be 1 you are getting. This is a positive. And whereas 3 to 4 in the sense displacement you will be getting as a negative you will be getting. And here force value will be getting as, this is 20 Newton. So here force and displacement will be negative, so work done will be negative. So you can act as 20 into 4 minus 3 will be getting as 1 will be getting, plus again 4 to 5 in this sense, again you can act as 10 into force into displacement. 5 minus 4 will be 1 you are writing. So when you are simplifying this one, here all the units is given as centimeter, it's given. So the answer also will be getting as, here 10 into 1, and here this 10 and 10, and this 10 gets 20 gets cancelled. So here we will be getting as 20 eggs will be getting 20 eggs. Be remember work done by the in the above x-axis, above in the sense here you can write as work done value will be positive. Below the below in the sense here you can write as work done you have to take as negative you can talk. Let us see the next question. Here a constant here where a constant for horizontal force 45 Newton is acting on the lower block. It produces an acceleration of 4 meter per second square. The two blocks move always together, it's given. And here find the work done by the friction on the upper layer, upper block during the displacement of 2 meter of the system is. So first we can talk about the frictional force acting here, acting on 2 kg mass. The force here applying along this direction, together it's moving. Here we can talk about frictional force which is experienced by 2 kg mass. Here it will be acting along this direction. And here you can talk about on 2 kg mass, action and reaction it will take place on the 2 kg mass. Here an opposite reaction force also it's going to be acting. So here you can talk about here frictional force on 2 kg mass. Frictional force on 2 kg mass. So F equals, here we can write it as m into a, you can take mass into an acceleration. So mass in the sense here it's 2 into with what acceleration the system is moving, 4 meter per second square it's given. So 2 4s are 8. Here we'll be getting as frictional force value will be getting as 8 newtons. So here both the blocks moves together so that we can take as right. Here we can take as frictional force, we can take as 8 newtons will be getting. Now what is the work done by this frictional force? Together they are moving in the sense here a kind of static frictional force is going to be acting. So here you can take work done by the static frictional force is It's a work done by static frictional forces. Work done by the static frictional force on upper block. Work done is nothing but force into frictional force into displacement you can do. It's nothing but here force value will be getting as 8 into displacement will be getting as 2 meters will be getting. So here 8 2 will be getting as 16 joules here. So this will be the correct answer. Let us see the next question. A body moves from a point A to point B under the action of the force varying in the magnitude as shown in the force displacement graph and the total work done by the force. Total work done by the force is nothing but here you can take as area you can take. Work done is nothing but area under Fs curve you can take. Area under Fs curve. So it's nothing but here from 0 to 5 when you are talking here you can take it's a triangle. Here you can take as half into base into height. Base is given as 5, height is given as 10 Newton, that is the area, and from 5 to 7 here will be getting as work done value will be force into displacement means here 7 minus 5 you can get it as 2 into you can write it as force will be getting as 10 Newton. So here it is 2 5s 5 5s 25 plus 2 which is nothing but work done value will be getting as 45 joules here. Let us see the next question. Here a force constant of a wire is given as K and that of the another wire is given as 2K is given. So when both the wires are stretched to the same distance, here then the work done they are asking. So here a work done to stretch the string or wire. Work done to stretch the wire. Work done to stretch the wire which will be equal to W equals here you can write it as half kx square you can take. Now here it's given as W work done is nothing but here which is directly proportional to K you can take. Since here what you can say for both the bodies here right x is given as same displacement you are moving. So one force constant is given as K, another force constant is given as 2K is given. Now you can take here W1 by W2 which will be you can take as K1 by K2 you can take. K1 is K it's given, it's 2K you can take, it's cancelled. So W2 equals will be writing as 2K will be. 2K this is 2 times of here will be getting as W1 will be getting as 2 times of W. W2 equals to 2 times of the W1 you are getting. Let us see the next question. A spring of force constant 800 Newton meter square, Newton per meter, has an extension of 5 centimeter. The work done in extending 5 centimeter to 15 centimeter they are asking. Work done to stretch the wire from one position to the another position is here you can take as half into K into here you can take as x final whole square minus x initial whole square you can take. So it's nothing but here half into spring constant or force constant value is given as 800 into x2 in the sense here you are displacing up to 15 centimeter. 15 is 225 will be getting minus x1 you are taking as here 5 centimeter, 5 5s are 25 centimeter square you have to take as 10 power minus 4 meter square. When you are simplifying this one here you can get it as 1 by 2. So here we will be getting as 400. Here 2 zeros and here it will be this is 10 power minus 2. So here it is 225 minus 25. Here we will be getting as 200 into 4 into 10 power minus 2 you are getting minus 2 and here 2 zeros gets cancelled. Here work done value will be getting as 8 joules you are getting. Let us see the next question. A uniform solid cylinder of radius is given as R and the length is L and mass M is lying on the ground. So initially a cylinder is given and here it is lying on the ground. Its length is given as L is given and radius you can take as R you can. This is the radius you can take as R you can take. Its length is given as L is given. So here this is an axis you can take, axis of the cylinder, and here the center of mass for the uniform bodies, it will be at the center will be getting, this is the center of mass you can take, or center of gravity you can take, at L/2 distance will be located. Now the next case here, if it is to be oriented on the ground with the flat circular end on the contact with the ground, the work done is. So now here you are going to be placing like this. You are going to be modifying here. You are lifting the cylinder like this. This is a position. Now here you can take here. This is here flat circular, and this portion will be touching the surface. Now here this height, it's nothing but here we can get it as L/2 distance you can take. Height of center of gravity will be at L/2 distance. Now here it's not required. Here it's not center of gravity. Here this is, here it's lying. So this length will be L. You can take length of the cylinder will be L. Now here you can take here what's the work done against the gravitational force. You are doing some work. It's W is nothing but here we can get it as work done against the gravitational force. Against the gravitational force. Work done against the gravitational force, here it will be stored in the form of the potential energy. First you can talk about, this is nothing but I am just taking as a change in potential energy. So here you are lifting the object. So here you can take as mg into h final minus mg into you can take as h initial you can take. So mg when you are taking common, here you can write as h final is nothing but here this height of center of mass will be located at L/2 distance, here L/2 minus. So here the height will be, it's nothing but here this height is nothing but radius only you are talking. So height is nothing but radius you can take. So mg into here L/2 minus r will be getting. So this is a work done, right, to take the body like this, right? mg into L/2 minus r you are getting. Let us see the next question here. A spring of 40 micrometer long is stretched by an application of force. If 10 newtons force is required to stretch the spring through 1 millimeter, the work done in stretching the spring through 40 micrometer they are asking. 40 millimeter they are asking. So here this is a string you are taking, you are applying some force, and here a restoring force is going to be acting along this direction. So restoring force acting on the body, in the sense here you can get it as F equal to magnitude alone I am writing kx. Then k is nothing but here you can take as F by s you can take. When you are applying 10 newtons force here, it is getting displaced 1 millimeter. So here you can take as 1 into 10 power minus 3. Here you can take as 10 power 4 newton per meter is the spring constant value. Then work done in stretching the spring to 40 micrometer. Work done to stretch the string formula will be half into k into x square you are getting. So half into k value we got just now here into x square. X square in the sense 40 millimeter. 40 millimeter you have to convert. Here it is whole square you are getting. This is whole square. This is here half into 10 power 4 into here it is 1600 into 10 power minus 6. So here we will be writing as this will get cancelled 10 power 4 plus 2 10 power 6, and this 10 power minus 6 gets cancelled. 2 many times, it's 8 times it's going. So the work done value will be writing as here it is 8 joules you are getting. Now let us see the next question here. A natural length of the spring is 60 centimeter and its spring constant is 4000 Newton per meter. A mass of 20 kg is hung from it. The extension produced in the spring they are asking. So here so force, restoring force experienced by the string is F equal to kx we can take, its magnitude alone I am just talking. So x is nothing but here we can talk about the elongation of the spring you can take. Elongation of spring. So here first let us calculate the elongation. X equal to here you can take as F by K you can take. Force value is given as 4000 Newton by this is here here So force is given as it's nothing but here you can take as mg by k you can take. Mass here it's given as 20 into g value you can take as 9.8 by here we will be getting as k value will be 4000 you are getting. So when you are simplifying this one here you can get it as here 110 gets cancelled. So here 2 times it's going. So 2 how many times here? It's 4.9. 4.9 by 100 you are getting. So x equal to 4.9 by 100. This is 100 will be getting. So here we can write it as 0.049 meters will be getting. Here it's given in centimeters they are asking. Here you can take finally the x value you can write it as it's a 4.9. This is in meters, so you can take 1 meter equal to here you can take as 100 centimeters. So 100 by 100 you can take, it is in centimeters. So x value will be getting as 4.9 centimeter. Here is the right answer.